Welcome to this clip going through how you can calculate a titration involving an acid reacting with two bases. I'm going to look at the OCR Chemistry A F321 paper, May 2015, question number 4. So let's have a quick look at this, and while I'm going through it you can have a quick read yourself. I'm just going to take you through a few things to be aware of as we go. First of all, the 2:1 mole ratio of base to acid in each of the two equations. So you're obviously reacting the acid with NaOH and also with NaHCO3. So you have to try and treat those two equations separately. Remembering that the ratio of H plus to OH minus is 1:1 and H plus to HCO3 minus is 1:1. But sulfuric acid is a diprotic acid. Or dibasic, doesn't matter which way you say it, but basically that means you've got 2 hydrogen ions per H2SO4 that are produced. Next thing to have a look at is the difference between the two titers will be the volume of H2SO4 needed to neutralize NaHCO3 only, because they already tell you that it takes 18 centimeters cubed of H2SO4 to neutralize only NaOH. So going through the question, first thing to do is part A. First bit, calculate the amount in moles of H2SO4 needed to neutralize only the NaOH in 25 centimeters cubed of solution X. You can do data moles equation moles answer. So the volume is 18, like we said. The concentration, like the question says, is 0.100. Multiply those two to get 1.8 times 10 to the minus 3. Now obviously the volume has to be divided by 1,000 to turn it into decimeters cubed. And that gives us the first answer. So now we can go on to the next part. I've color-coded it so you can see which part of the data moles equation moles answer technique is now being applied. So the equation says that the ratio of H2SO4 to NaOH mole ratio is 1:2. So to get the moles of NaOH, you multiply the moles of sulfuric acid by 2. That gives you 3.6 times 10 to the minus 3. And that gives you the concentration of 0.144 moles per decimeter cubed. So now we can check the mark scheme and just see we're in the right place so far. Going on to the next part, just reminding ourselves a bit about the two equations. The difference between the two titers is the volume of H2SO4 needed to neutralize NaHCO3 only, so we now make use of this information. So I'll put the information at the top there just as a reminder, and we can see that the volume is 11.50 centimeters cubed, and the concentration of H2SO4 is 0.1. So we can do data moles equation moles answer again and put that information in. That gives us the number of moles of H2SO4 this time as 1.15 times 10 to the minus 3. The mole ratio of H2SO4 to NaHCO3 is 1:2. We just remind ourselves using the equation. And we just put in the moles of NaHCO3 as 2 times 1.15 times 10 to the minus 3, giving us 2.3 times 10 to the minus 3 moles. So that's only in 25 centimeters cubed, but they want the amount in 200, so we've got to scale up accordingly. So we multiply 2.3 times 10 to the minus 3 times 200 over 25, which gives us 0.0184. Now what we need to do is convert that to a mass for the final part of the question. So adding up the atomic masses of each of the components of NaHCO3, that gives us 84 grams per mole, and we multiply that by 0.0184, which gives us 1.55. So just take a moment to memorize those two values, the 0.0184 and the 1.55, and we can just check our answers there. And you can see what the 2 marks are for in the first part, and the final mark is for 1.55 to 3 significant figures. Okay, hopefully this has been a useful look at how this type of question is dealt with, and thanks for listening. Until next time, see you soon.